Think we are live. Yep, we are live. Welcome to Big A's Network Emporium. Today we're going to be taking a look at OTV and its first hop redundancy protocol isolation using the CSR 1000V as our OTV, if you want to call it, as our AED, authoritative edge device that controls all of the overlays. So, get my Twitch chat here up and going. Pop that out so I can see it. That'll behave today. All right. So here's what we're gonna do first. Let me make sure my mic is up good. Yep. Let's take a look first and do a recap of what we did last time, which was configure OTV. So we have 3 different sites. We have an HU site, we have a West data center site, and we have an East data center site. And for each site, we used a CSR 1000V to configure OTV to stretch a data center interconnect, so we could stretch layer 2 across multiple sites. Because normally this would be 802.1q trunks, then you got to deal with spanning tree and all that wonderfulness that comes with spanning tree when things have to converge and reconverge. This allows us to have those layer 2 networks at each site. So let's take a look and do a quick recap of how we have OTV configured. So let's do a show run here. Include OTV. All right. So here in OTV, you're going to have a layer 2 interface, and you have to have a layer 3 interface. That layer 3 interface is going to be known as your join interface. That's how each OTV authoritative edge device in each site, if you want to put it, the best way to put it, each OTV instance is a site. That's how they're going to be able to communicate with each other and say, here are the VLANs that I am stretching across to the other OTV sites. So if we do a show run here on our interface for overlay 1, we see here in CSR 1000V, you can't do VLANs. So what you have to do was known as a bridge domain. In the bridge domain, you think of it as in the 802.1q tag. So you're gonna have a tag on there. So the 2 VLANs that I'm doing across this overlay are VLANs 50 and 51. So this is the overlay. This is what you configure. In your overlay, which is what's gonna actually encapsulate those packets so they can go across the network and then go to another OTV. I think I have it. Let me double check. I believe I have it. I've been on turn on. Thanks, mentors. Let me just double check and make sure I do have the recording turned on. But I believe it is. I think we should be good. Let me go to my dashboard. Sure, I'm checking out. I'm checking over here on my other screen here. Setting. And automatically save broadcast up to 14 days. Yep, I have it turned on. Let's see. I'm gonna bring that over here. There's that thing here to make sure that I'm actually keeping the video. So that should be good. We should be good on that. So let me take that back to the other screen. All right. So let me get my chat back up as well because I don't want to lose that. There. Here we go. So on this overlay interface, which is going to encapsulate all of those, everything in that layer 2 that you have told it, which is VLAN 50 and 51 in this instance. It's going to take those, encapsulate it. It's going to add, I think it's 42 bytes to the header, and that's why you have to use jumbo frames, or else it won't fragment it, and you do not want it to fragment it. You want it to transfer the packet as is. It's going to add some information to that frame to tell it. It's going to encapsulate the MAC address and IP address, and it's going to tell it, hey, it's going to shoot to the other side and say, I have, this VLAN, and I'm extending it across. So we have an overlay interface, and here you tell it where the other adjacency servers. Those are what your authoritative edge devices are going to be called. They're going to be your adjacency servers to say, here, I need you to peer up with this other OTV instance, and we need to share information on these VLANs, these layer 2 extensions that we're doing. So I told it what other adjacency servers there are, which are the other 2 OTV instances. I'm on the West OTV instance, so it's telling it the HQ instance and the East instance. So now when we look at the join interface, like I said before, you have to have your overlay interface, your join interface, and your layer 2, your trunk down into your network. So those are 3 things that you will configure inside of OTV, the 3 interfaces that you will configure. So let's look at, I have to remember which one. I think it's G1. Oh, sorry about that. G1. All right, this is what's known as our join interface. It is connected to our layer 3 core. And you see we've set the MTU to 9216, so we've taken it to the max that the jumbo frames can go. We've given it an IP address, and we do a route. Since this is the only thing that's going to be doing layer 3, we have a default route that connects it to the 21.2 interface, which if you look here, GI1 is actually connected to ETH11 on side of my layer 3 core, which is a Nexus 9000V. So if we take this and we look at show OTV adjacency, we can see that it has 2. It sees the East OTV instance and it sees the HQ OTV instance. So let's move this to the side here. So it sees the other 2. And we see here that we're going to extend the 172.16.1.0 network, /24 network. So I have in here, let me minimize those. I have, excuse me, I have 3 tiny core Linux virtual machines running that are configured with IP addresses inside of this subnet. I have no layer 3 interface, so there's no SVI here, here, or here. So right here, if I go to my QMute instance here, and as you can see, this is the West. So if I do if config, you see I've given it an IP address of 172.16.1.13. And just to show you, if I go to the core here, I'm going to do a show IP int brief. You will see there's no 172.16.1 anywhere on this. There's no layer 3 interface, no SVI, no configuration on an Ethernet interface. So this 172.16.1.0 is purely layer 2, purely layer 2. So if we come over here, go there, and come on, QMU. See if I can make this a little bit bigger. It's gonna. Okay. Looks like it doesn't want to get bigger on me to make it where it's easier to see the actual things here. So this IP address of HQPC is 172.16.1.11. The east is 172.16.1.12. So let me show you on the east. Got 12. And then on the west is 13, and HQ is 172.16.1.11. So now, since we come over here, let's go to the west, and we show not OTV adjacencies, so that we're both that the other two instances of OTV are actually, we can see them and we're communicating with them. They're all up. So now we're gonna do show OTV routes VLAN 50. So I'm gonna stay on there. So now you see there's no routes there right now because nothing is talking to each other right now. They're not doing anything. So what we're gonna do now is from here, from the west, we're gonna ping 172.16.1.11, which is the HQ instance in VLAN in that VLAN at 172.16.1.0 VLAN. So when I ping, should not see anything. Great, it would decide it wants to route. Let's see, stop on me. Now I love it when there we go. Now I had to catch up for a second. So now you can see it's pinging. It's pinging 12 here. So that shows that now when I do a show OTV route, as you can see now, I have these two MAC addresses, which I have learned from the HQ OTV, and I've learned this one from the East OTV, because if I stop this, let's stop those pings. If I do a config, you see that the MAC address of 172.16.1.11 is that 0C B190.3B0900, which is this MAC address there. That shows that it learned it from HQ, and then it's learned the 8100 from East. So if we go to the East, I know it's kind of hard to see it, but it has the 8100 MAC. So we confirmed that we have layer 2 adjacency. Now if I try to ping anything else, not 172.16, 192.168.1.1, I cannot ping that because there is no layer 3 interface in this layer 2 extension that we have. I should say that's associated with this layer 2 extension that we have. So you cannot ping outside of that subnet. So that it works fine for layer 2, but then when you need to go out, there is no gateway. So thanks for the choice. Yeah, I have to figure out this. What I may do next time, if I do another OTV session, is I may do a Windows virtual machine. TinyCore it's a small virtual machine, so it's less resources. But I mean, I have a ton of resources on my machine. You see, I'm only using 26% of my RAM and 14% of my CPU. I'll probably use a Windows machine next time to make sure I can do that. So now what I'm also going to show you here is I'm going to show you a quick packet capture. So when I'm pinging that interface, that machine, which is I'm using the West PC, and I'm pinging the HQ PC. If I come down here, get in GNS3, and I start a packet capture. We're going to start up Wireshark. It's going to automatically start that packet capture. Let me break that down a little bit. Get the QEMU going on the other side to show that we're still pinging. It has to find the interfaces. And it's going to start capturing on that interface. So, so I'll show you something here. You see that these two are talking. You come here to this. Right now, you can't see anything because it looks like a bunch of gobbledygook going across. But if I come here, because Wireshark can't, it doesn't know how to decode it, because inside the MPLS it does something. I think it's with the capture word. It can't tell. It's looking for it, but it can't tell it. So what I'm going to do is I'm going to tell it. Here it is. I'm going to say do Ethernet PW, no CW there. Yep. And we're going to go OK. And now, since I've done that in Wireshark, now you can see that 13 is pinging 11. Before you would have seen it, it just looked like a bunch of gobbledygook going across, because Wireshark didn't know that since OTV is a fancy GRE tunnel with MPLS in it, got some ISIS going on in there. When it's looking for that control word, it doesn't know that there's no control word inside of OTV. So we have to tell it that there is no control word. So then it can actually see the package. And now you see that I'm pinging across. Now, if you look at it, you see here's the two instances of OTV. Those are my authoritative edge device, my adjacency servers. And then what it's doing is it's encapsulating. There's your GRE. And then here's your MPLS. And you see this MPLS label. The MPLS label is 82. And what it does in there is it adds 32 to the VLAN number. So that's how it knows what VLAN is where. So, and then once it encapsulates that, here is our original packet, which is going from coming back from 172.16.1.11, which is our HQ PC. And then here's the one for going to our West PC. So we are going to stop that capture. Stop and quit without saving. Close that off. Stop capture. So you've seen that we can see the packets now. So now what we're going to do is we're going to come here to HQ so we can ping some other things. We're going to come to HQ. I have to make sure I turn this feature on. Show enable. So we have interface VLAN turn on and we have HSRP turn on. If we're going to do HSRP, it's a feature. This is nx-OS. You have to turn it on. It's not like iOS. It's just on by default. So now we're going to come through. We're going to configure this interface. So I'm going to configure VLAN 50 with an IP address. Now, 22.16.1.1/24 redirects, no IP proxy ARP, direct to broadcast. Shut that interface, which is already up. So now, we'll show up here in brief. We see that VLAN 50 is up. Now, if we look at it, we go to here. I said I wanted to ping it from the west. So 192.8.22.1. I still can't get there. But now I can. Sorry about that. I can now. All right, because I have a layer 3 interface, so I can ping out of there. Go test. The HSRP going. So what's happening is it sees this interface, like if I go here, if I were to start another capture, in there, start capture, come back to the west. Once my Wireshark decides it wants to start, waiting for Wireshark. Where are you, Wireshark? Get started. Now, look at it here. Start to ping. Back up here. There. Now I got some traffic going. Come here. W. There we go. What's happening is this is traveling, which it should do. It should travel up here and then hit that interface here. That's where it should join. That's what drop off at. Let's do something different. Let's stop this capture. Of course, you know that's going because it sees this directly connected interface. So now, if I do down here, and I'm going to configure I'm going to configure something else on this one. So let's log into this router. My son just walked into the room. Buddy, I'm recording. You go back and listen to your stuff, and I come check on you, okay? All right. See you, buddy. You can take it outside. Take it with you to your room. Sorry about that. Got my kid jumped in. So let's do this. Let's look at what we have here. Let's configure an interface here. So let's do this, and we're gonna do, let's do interface VLAN 51. And on this one, we're gonna do IP address of 172.17.1.1/24. And if we look at it, so IP in brief, VLAN 51 is up. Now, what we want to do, I actually want to add it to EIGRP, so interface VLAN 51. I'm going to IP router EIGRP 100. So now, if I come over to this HQ instance, should be able to ping that interface that I just created. 172.16.17.1.1. I can ping it. That's there. So now, if I come to here, I can't ping it. And the reason why I can't ping it is because that 172.16 is not in EIGRP. So, by all accounts, technically here, I should be able to just ping straight to that VLAN interface. So what I'm gonna do is, I'm gonna come up here to what was it? My HQ core. Then, as you can see, I have brief that VLAN 50 interface. I'm going to come here and do this. VLAN 50. And then let's throw that joker into HSRP. Boom. Now I can ping it. But let's go take a look at a packet capture. And I want to show you something. We're pinging from the West PC to an SVI that's in the West data center. But because of how that goes, since I don't have a SVI, a layer 3 interface configured on my West, it has to trombone up and then back. So we look at, if we get here, now you can see that in order for this PC to ping an SVI that's on this layer 3 core, it has to go up OTV through EIGRP back and then back up. So it's a trombone effect. So I'm going to leave that capture going. So what we're going to do is I'm going to come to the HQ core. And what I'm going to do is I'm going to change the interface on VLAN 50. And now I'm going to change its IP address to 172.16.1.2/24. And should stop here in a second. Show up int brief. .2 show run int VLAN. Oh, technically it's not acting the way I wanted to act, but let's go take a look at that. Gotta go look at one thing on SP. $13. There we go. I don't know what. Stop the capture, so I stopped the ping. So at the West of terminal 2.17.1. J consider effect. Here's no. Oh, I'm sorry. Well, no, that shouldn't work. Hold on. Do this. VLAN 50. So. Okay. Stopping. Not seeing it. Because my sequence numbers aren't in. Oh yeah, I'm sorry. Now we got it. I'm getting the request, but there's no reply coming back. It's actually coming up this way. And then let me look at, I need to look at one thing here. If I do a no shut on the interface. Fine, but there is. It knows because it's exiting out. Hold on. Let's do this. Considering the fact that I've turned the default gateway, it's not in there. So I'll be int brief. So look at, let me go to OTV real quick. So route 51 show run show int vlint. One 7 right there, so it has learned it. But here's the thing about that. All right, so if we do show run and VLAN 1, it's an EIGRP. This side knows about it. It should not traverse up this link. It should literally stay inside here, but since it doesn't have a default gateway, it has to go back up here and then trombone back down. So what we want to do is, let's configure some HSRP. We're going to leave this going so we can keep that ping going. Show run VLAN 51. I'll make 50, sorry. All right, so now we're going to do some HSRP on here. VLAN 51, 50, sorry. We're going to do HSRP version 2, and then we're going to do HSRP or VLAN 50, and then have to set our IP on here. IP 172.16.1.1. And then we have that HSRP address going. So now if we do show HSRP active, make sure everything run in VLAN. All right. Version 2, HSRP 50. A1 dot should be right. 50 1.1. Simple as we can get there. Now that's at HQ. Now let's go over here to our West core. We're gonna do an int VLAN 50. I'm gonna do an IP address of 172.16.1.234/24. Alright, so IP proxy ARP. No, IP direct broadcast. Then we're gonna do an HSRP version 2. HSRP 50. And then our IP is gonna be 172.16.1.1. There. Oh shit. Now so int3. Now we have a VLAN 50, a VLAN 51. And then you can see we pinging there. Now, if you look, the HSRP by configuring it here, now it is no longer going up across because we haven't stopped that capture on this interface. As you can see, now we have first hop redundancy protocol running on the west core. So now instead of having to ping up OTV and back, we put HSRP on the west side, and now it has a local gateway that it can go out of. So before, if it had to ping something here in VLAN 51, it had to go up to the HQ core because that's where our gateway was at, our current default gateway. It had to go up and then back. So by putting HSRP here, and the fact that it filters out HSRP there, so if we do a show HSRP active, you see that it's active here at the west core. And then if we go to the HQ core, HSRP active, it's active right there at the HQ core. So we have 172.16.1.1 at both locations. That is one of the beauties of OTV, is now I can have the default gateway at multiple locations. It's going to filter out that first hop redundancy protocol. So now if I have to ping something from the west, if I configure something in the west and I have another subnet here that's local to the west, instead of it having to go up and trombone back, it can just switch, it can just route right there. That is the beauty of OTV. So as you can see, if we go back to that Wireshark transfer, I'm thinking Wireshark capture, as you can see, there are no, and I do mean no, there are no packets coming from our West PC going to the interface here on our West core. So I mean, it's simplest way to do HSRP. Now, of course, if we did a full redundancy, which I may do a lab on that later, you would have two 9Ks or two Nexus 7000s here in VPC, and then you can get all sorts of, you have another OTV instance here, so that you have, when I tell you have a site redundancy out the yin yang, you will have a site redundancy out of the yin yang. So just to recap what we've done tonight, we have OTV running. Let me pull up here. We have OTV adjacency here. So we have all sites up. We have routing where it's learning the different IP addresses. And then when we come to our cores, the first core, show HSRP active, we have that HSRP is active here. And then we come to the HQ core, that HSRP is active. Just to show you it's active, that HSRP is active there. So now if I have this PC, if I configure another SVI or another Ethernet interface connected to something in our HQ core, it has a default gateway. It can just go in and route to the next interface. It does not have to go over OTV and trombone. Because if you think about it, when you had let's say you had the original HQ data center, and that's where that 172.17.1.1 was originally created. And now you've went into two co-location facilities or another building, remote site, whichever one, and you wanted to, for disaster recovery, you wanted to make sure that you could put VMs here and here that were using that 172.17.1.0 network and the 172.16.1.0 network by putting HSRP at each location and using OTV to actually filter it out, so to make sure that each site has an active. So as you see, there is no standby router. All the active is local. active local, standby unknown. So with that, oh, okay. Yeah, yeah, mentors. I may expand that and actually do VPC on using the 9000V image and the CSR 1000V. Actually, let me give you a preview of that. So let me copy all my configurations real quick that I have made changes to. For the OTV. Go over to rest OTV. Which doesn't do anything, but let's just make sure we have those in there. So close all these windows out. Let's stop that capture. Close Wireshark out without saving. Close these other. Check that. Make sure I did save. Run start. Let's copy run start. And we copied there. I'm gonna tease you. So watch this. If I go and open one of my other projects, which I did it under, I want to say it was, I gotta remember which one I actually did it up under. I want to say it's this one. Double check. This is that configuration. I've actually started it. So you see these two are in VPC, and I have OTV in between each one of those. So yes, that's probably going to be my next stream. I got to do a little tweaking to it, but I'm actually going to have VPC running. So you see VPC. Not only will you see VPC on the 9Ks, but you will see multi-site OTV. And just to give you a little teaser, when you have that redundancy in OTV, let's say it'll choose with a authoritative edge device, and say, hey, this OTV instance, you handle all the even VLANs. This OTV instance, you handle all the odd VLANs. And then we can actually shut this down. This will pick up and keep everything going. So that's going to be the next stream. Probably going to hold me to it, but I'll work on that lab. I got a few things to tweak. So hopefully Wednesday, we can go Nexus 9000V VPC and multi-site redundant OTV with HSRP going across. So I think that'll be all for tonight. We actually, under an hour to show that. So stay tuned. There's be more to come. So I guess now, with that being said, we're going to end the stream. Thank you for joining Big Abe's Network Emporium, and we will see you on Wednesday.